Graphene is a unique nanoscale form of carbon that is disrupting legacy materials, bringing step-change improvements in performance across a wide range of industrial and consumer applications. From energy storage and electronics to everyday materials, graphene enables products that are better, stronger, and lighter, while increasing durability and improving sustainability. Graphene is leading the era of new, advanced materials.
Thank you everyone for joining. My name is Terrence Barkin. I'm the Executive Director of the Graphene Council. And together with my colleague Chirag Ratwani, who is a material scientist working for the Graphene Council out of the UK, we're going to discuss how to identify and source the right kinds of graphene for your applications, as well as to find suitable supply chain partners for these materials. For those of you who are not familiar with the Graphene Council, we are a trade and professional body, as well as providing an extensive range of services to the graphene sector. We were founded in 2013, so we've been at this now for more than 10 years. Our network connects more than 35,000 material professionals. We work not only with the graphene producers in the sector, but also with end user organizations, large industrial companies, chemical companies, automotive, aerospace, industrial product makers, sensing devices, etc. Any of the vertical markets that are using graphene, we work as a neutral, independent body. We ourselves do not make graphene. We ourselves do not sell graphene. We are completely independent and have no interest in any of the graphene companies. So we work as independent subject matter experts to facilitate the application of graphene on an industrial scale. And that means understanding the sector and then connecting partners which have matching interests. Graphene, of course, has garnered tremendous interest because of its unique properties. This is sp2 bonded carbon at the nanoscale, so single atomic layers up to and including 10 layers of carbon is considered graphene according to the ISO definition of graphene. And because graphene has all of these properties that you see in front of you, this is what makes it so interesting. This is also why graphene can be used for so many different applications, because in one instance, you might be using graphene as a thermal heat spreader, and then you also find at the same time that you've gotten improved strength or UV resistance, or you've reduced flammability for the part that you're using it for. And we've seen this quite often, that graphene is used to improve a particular target characteristic, but because it has all of these properties inherent in the material, it often gives additional benefits as happy surprises. So that's not very uncommon. So this is why graphene is so interesting. But now we need to talk about what really is considered graphene commercially in the real world. And from a scientific perspective, one could argue the only thing that is graphene is a single atomic layer of sp2 bonded carbon. But for commercial purposes, and according to ISO standards and evolving other standards, such as with ASTM that we're working on, graphene includes a whole family of materials that includes more than one layer of carbon, up to and including 10 layers, and even graphene nanoplatelets, which would be in excess of 10 layers of the sp2 bonded carbon. Now, besides these definitions, we also have materials like graphene oxide. Now, graphene oxide contains about 35% oxygen by weight. It could be 30 or 40%, different levels. And graphene oxide, or then reduced graphene oxide, behaves differently than graphene nanoplatelets or graphene flakes. For example, pure carbon graphene is hydrophobic and is very electrically conductive. Graphene oxide is hydrophilic and is no longer electrically conductive because of the oxygen content. So even though it's in the same family of material that we consider graphene writ large, it behaves very differently. And this is one example of why choosing the right type of graphene for your particular application is a little more complicated than maybe some people assume. Graphene can also be produced and delivered in the form of a dry powder. It can be in a solution, or it could be in a paste format. Those also have implications on how you can use graphene or apply it to your application. And then we also have a category of materials called functionalized graphene, which have been intentionally altered with chemicals on the surface or the edges of the graphene flakes for different reasons. For example, it might have a surfactant added to it to improve its dispersibility in your host matrix. And so when you take all of this together, the different chemical combinations, the particle morphology, the layer count, we end up with hundreds of iterations of graphene material that is in the same family, but does behave differently depending on the application that you're looking for. And because of all the properties that I described a little bit earlier about thermal and strength and electrical conductivity, et cetera, we see that graphene can be used in many different applications that have very little to do with each other. But it's because graphene is used in these different applications for different reasons, such as lubricants. We have graphene that's been used in motor oils to improve lubricity and improve the thermal transport properties of that motor oil. That's extremely different than using it, say, for an electronics application or in a sensing application, even though ostensibly it's pretty much the same material. And here we kind of see a rough breakdown of different types of graphene. So you could have monolayer or single layer graphene that is quite well suited for electronics type applications versus what we call bulk graphene or multi-layered graphene, typically presented as a black powder, which might be used in some other applications where primarily it's used as an additive. For example, in composites or even in concrete and cement applications. So it really is a matter of tuning the right type of graphene for your particular application. We've come across quite a few people in these past years who said we've tried graphene, but it didn't work. And one of the most common reasons is you didn't have graphene at all, or it wasn't the right type of graphene for your application. Secondly, when adding graphene, especially in these bulk applications, we find that using very small amounts of graphene is more effective than using larger amounts, which is counterintuitive. Most people would think if I've used graphene and it didn't work, I'll try adding some more and see if that works better. When in fact, it's often the case, you're going to get a better result by actually using less graphene. The other thing we want to talk about with graphene is the perception that this is a material that is just too expensive to be considered to be used. And that truly is not the case for two primary reasons. One, the ability to produce graphene has improved immensely over the last 10 years, where we now have close to 25,000 metric tons of bulk graphene production capacity. And that is going to ramp significantly in the next years. We have a lot of graphene production coming on stream with new producers or expanding capacity for our existing graphene producers. And the other factor to keep in mind is that you're often using an extremely small amount of it. In the case of concrete, for example, which is tremendously price sensitive, you might be using 0.03% by weight. So this is, tens of grams per metric ton of concrete where you're using graphene. And so when you're using such a small amount of it, even if the graphene itself on a per unit basis seems to be an expensive material, in fact, when in use, it's quite economical. Here are some very large markets that we have identified that graphene is being used in and has been proven to be effective as an additive to improve the performance. And we see that the demand potential for graphene is quite extensive. So these give some of the average market prices, and at the very low loading factors, because graphene can be used in some of these high volume markets, even at a very small percentage rate, the volumes and the dollar values of these markets is quite significant. And most of the development for graphene, I would have to say, is confidential or under NDA. we, as the Graphene Council, can see that graphene is being put into a lot of these products like rubber, elastomers for tires, for example, or polypropylene or PET or PA6 nylon. We know that graphene is being used in these and that it has been proven effective. You may not hear as much about it because almost all of the companies working on developing graphene applications do it as commercially sensitive information and trade secret. And so it's not made public. So a little bit frustrating for us because we would love to tell more people about these applications, but we do see these applications being evolved, and we assume that there are going to be very high follow-on rates for adoption as these come to market. If we look at the graphene value chain, we want to just kind of give an overview of how we see this field. You have graphite and carbon source producers to produce the raw material. And I would like to let you know that today we've identified a dozen different raw materials that can be used to produce graphene. It's not just produced from graphite, which was the original and traditional source of raw material for graphene production, but we also have carbon-bearing gases like acetylene or methane. You have recycled plastics. You have biomass, such as the waste product from the lumber industry or agricultural industry. You can have graphene produced from coal or coal byproducts, petroleum byproducts, and many other sources of carbon. So on the raw material side, there is a range of materials that can be used for the production of graphene. Likewise, on the production methodology, the original method was micromechanical exfoliation of the graphene sheets, basically taking the individual layers of carbon and separating them until you got to a single or very few layers of carbon. But there are electrochemical processes, many different types of pyrolysis or joule heating, for example, that could be applied. And so there's a dozen different ways of making graphene with a dozen different feedstocks. In the next stage, once graphene is produced, we do have a post-production process, and this would be things like functionalization or making master batches, putting the graphene into a carrier or a host product to make it more usable to the end user. And then we have other applications that would be the end user. So you have graphene that goes into products. For example, Callaway golf balls have graphene in them. That's a brand that I like to use when I play golf. And you have shirts, textiles, all sorts of products. Victoria bicycle tires, for example, their entire line contains graphene in it because it makes the tires last longer without losing friction. And there are quite a number of these examples. So those would be the end users that are actually leveraging graphene into the products that they then bring to the market. And if we look at some of the graphene companies, you will see some companies that are producing graphene and selling it as a material for further processing by other companies. Or you could also have vertical integration, where a company, for example, controls a graphite mine, makes graphene out of it, and then turns it into a battery anode material, which they then sell or even go so far as to make their own battery cells. So there are different strategies or plays within the industry. There's some companies that specialize just in post-production manipulation of graphene. So these are companies that don't even make graphene themselves, but they specialize in developing applications or making master batches. And this is another source of material that if you're an end user thinking about how to use graphene in your application or in your product, these are other companies within our environment that we work with and that we have as members in the Graphene Council who can help you unlock what graphene can do for your product, even though they themselves may not be the producers of the actual graphene, but they put it into a form that's more easily used for you as the end user or the product developer. So with that, I want to hand over to my colleague, Chirag Ratwani. As I mentioned, he is a materials scientist. He works for the Graphene Council based in the UK, and he's going to discuss some work that we've done in evaluating the commercially available forms of graphene in the market. So with that, Chirag, I'm going to hand over for you.
Awesome. Thank you, Terence. Now, I'll take on from here. So now when it comes to selecting the graphene material for your application, it becomes challenging, especially for the end users or the OEMs, to identify the right material. And the main reason is there are hundreds of options available in the market, all of them significantly or slightly different from each other and having different dominant properties. So there are about 10 key properties that should be considered for selection of the material. The first one is the purity and the quality. That means how pure the graphene is, what are the residual contaminants, and what is the ratio of the carbon. Second is the layer number, which essentially differentiates graphene from bulk materials like graphite. The third is the size and the shape, which is the morphology of the flakes, or the lateral size and the aspect ratio of the nanomaterials. The fourth is the surface functionality, which is the way, which also affects the way these nanofillers bond with the matrix. This includes different functional groups on the surface, including hydroxide, carboxylic acid, etc. Other one is the specific surface area, which would be critical for applications such as supercapacitors, where surface area has a dominant role. On the right, there are factors which are a bit more case specific. For example, if your end goal is to make the material electrically conductive, then you need to see the conductivity of the filler or the base material. Second is the mechanical properties of the filler itself. Third is the chemical stability. The next is the cost and the scalability, because if you go through the application development process and you develop a product that works for you, you need to make sure that you can get that product on a commercially at a commercial scale, and you're able to put this product out in the market. And the last is the environmental impact, because one of the key reasons for using graphene is the goal to reach the net zero targets, with graphene being a sustainable carbon source. So these are the factors that need to be evaluated before purchasing the product. So for successful material selection, we require an accurate assessment of the application requirements, and these application requirements must then be matched to the pertinent property data so that you are able to select the right type of graphene. So as the Graphene Council, we have analyzed more than 650 commercially available technical data sheets from different producers for graphene. This data is then extracted and tabulated with consistent units, because with different properties, most of the different TDS report data in different units. And then this data has then been segregated into 19 essential graphene characteristics. Now, each TDS has been assigned to one of the 5 categories, which is graphene. Next is the graphene oxide or the functionalized graphene. There is the dispersions and master batches, CVD or the epitaxial graphene, and last is the graphene products. Now, this segregation has been done based on the description provided by the supplier of the TDS. Now, when we see at the total number of TDSs, we see that certain properties like the material form or the lateral particle dimensions are reported more often, which is almost more than 60%. But other key properties, for example, the ratio of the sp2 bonded carbons, the layers of the carbon atoms, or the z-axis dimensions, the oxygen content, or even the surface particle size. These are almost reported less than 10% of the TDSs, and it is very critical to understand how these factors play an important role for your final application product. So for this, we have taken a few examples of the key properties to understand what's the difference. Now, the first is the minimum carbon content. So we have analyzed 3 different categories: graphene, graphene oxide, and dispersions. And we find that with graphene, the minimum carbon content varies from 100 to all the way 60%. And the same with the graphene oxide, it goes from 100 all the way down to 35%. Now, this becomes very confusing for an end user, because the only way they can rely on the product is by the TDS. And when they read that a TDS has 90% of the carbon and it says graphene, or it has 90% carbon but it says graphene oxide or functionalized graphene, and they do not really understand what they are working with. And that's why certain consistency in these reporting formats is essential. Next is, as Terence said, the ISO standard defines graphene as a carbon allotrope with up to 10 layers of sp2 bonded carbon. This chart here shows the data reported from graphene based TDSs, and we see that some of them report the maximum number of layers, even up to 15, 20, and 30, and then it is still called as graphene. So at this point, it makes you wonder that should 10 plus layered carbon still be called graphene, right? And how does the consumer know that is this graphene, it is not graphene, or is it just graphene nanoplatelets or just bulk graphite? Other thing that we saw is that a standardized TDS format requires you to report certain characterization techniques, the results from them, such as from the Raman spectroscopy, the SEM or TEM microscopy, and the AFM microscopy. We found that less than 10 companies report all the essential characteristics and characterization results for their graphene products. Other thing is that when it comes to critical properties, it is essential to report them in terms of ranges rather than a single specific value. That is because the material could be homogeneous or heterogeneous, first of all. Second is that graphene being such a versatile material, it can be used for different applications. And for certain applications, the minimum value could be important. For certain, the maximum could be important. So they are putting that into an example that, for example, that if we consider the lateral size of graphene, then a company working on composites who wants to enhance the strength of the polymer might prefer graphene with a larger lateral size, and company using graphene to enhance the textiles might want to use the smaller lateral size so that it does not clog the spinneret. So that's why having an idea of the minimum and the maximum values is really important. Yeah, so with this, I'd like to hand it over to Terence to talk a bit more about the graphene classification framework, which at this point is being converted into an official ISO standard, and this helps understand what exactly a material is. And yeah, thank you, Terence.
Thank you, Chirag. Appreciate that. I want to underline what a massive project it was to catalog 650 different individual graphene products that are commercially available on the market today. No one else has such an inventory of these materials, but this is a tremendous resource that we have within the Graphene Council. The graphene classification framework was developed by more than 100 subject matter expert volunteers, which included regulators or representatives of national metrology institutes. And we identified 19 key characteristics of graphene that are commercially relevant, which are listed here. As Chirag said, this is now being developed into an official ISO international standard, which we expect to be balloted and published still this year. This is really important work that the Graphene Council has developed, and this graphene classification framework not only identifies the characteristics that the industry has identified as commercially relevant, methods of testing and characterization for those values, includes a syntax on how to describe a graphene material in a neutral, consistent manner, as opposed to market nomenclature or branding. And lastly, we have developed a templated technical data sheet that complies with this classification framework that we encourage all graphene companies to use so that consumers or purchasers of graphene material are able to compare like with like on the same basis and format of information reported for graphene. So that's really important. So this is a major advancement in providing transparency and consistency to the market. And as we mentioned, this technical data sheet that is provided is part of this classification framework and will be part of the standard. The Graphene Council actually provides testing and characterization services. And when we do that for companies that have their material tested with us, we provide that data in the form of the technical data sheet that's compliant with this classification framework. So also, having tested many materials directly ourselves or through our partners, we have a very good understanding of which companies are producing what kind of materials. Unfortunately, today, the vast majority of graphene producers in a which there are almost 300 companies that claim to produce graphene, report very little data, and it does make it next to impossible for a consumer of graphene to be able to compare those materials like for like. And most consumers of graphene don't have the intention or the ability to actually test materials, say for quality control measures, because testing and characterization of graphene materials does require some specialized equipment as well as know-how in sample preparation and interpretation of the testing results. But we can help companies and do help companies on a regular basis with these kind of testing services. So how do you find the right graphene supplier? Well, we have a list of member companies that belong to the Graphene Council, and we also have verified graphene producers, which I'll describe in just a moment. So if anyone visits our website, you'll see immediately on the upper right-hand image, you can go to a list of Graphene Council members, and we certainly encourage anyone who's looking to use graphene or to develop applications with graphene to work with member companies of the Graphene Council. It is our feeling that these companies, by being members of the Graphene Council, help us to advance standards and to provide information to the industry about graphene. And this includes our interface with regulatory bodies, also with work on health and safety issues for graphene and making safe workplaces. So we feel companies that are members of the Graphene Council demonstrate dedication to the industry and professionalism by being a part of the council, and we in turn help the industry to advance in a transparent and trustworthy way. Now, the Verified Graphene Producer Program is the only program that exists today with an in-person inspection of graphene production facilities and processes. So when we go to a graphene company that has invited us to do the verification program, we track in their facilities from raw material intake through the production process until the product is going out the door. And what we look for are quality control processes. We review books and records. We look at health and safety practices in the facility. We take an audit of the material that they're producing and then have that fully characterized according to the classification framework to ensure that that company makes what they say they make. And we also verify their capacity claims so that if they claim they can produce 10 metric tons of graphene a year, we look at their production process, volumes, batches, et cetera, to determine if indeed they have that capacity. And there are 6 companies that have successfully completed this, which you see listed here on the screen. These companies have all been personally inspected and verified to produce what they say they produce at the volumes that they claim to produce them. And so they are verified graphene producer companies. And we certainly encourage anyone looking to work with graphene to consider these companies or member companies of the Graphene Council in first priority. If you're interested in in-depth information about the graphene sector, we produce a product called the Graphene Report, which is in 3 volumes. It covers everything from production methods, market conditions, and pricing trends, all of the applications where graphene is applicable. And we also profile more than 200 commercially producing graphene companies in profile. This is a benefit for corporate members of the Graphene Council, or it can be purchased separately as a report. I just wanted to put that out there so people are aware that this resource is available, and it does include several hours of direct one-on-one consulting with us on your particular application or if you have any questions. And with that, that'll conclude our presentation. We are here to help individuals who want to use graphene to unlock all of its tremendous properties, to enhance your products, to give you competitive advantage in the marketplace, or to solve difficult engineering problems. Could be energy density in batteries or lightweighting car components. And with that, this is our contact information. I'm going to leave this up here just for a moment, and we are now going to go into questions. And I hope everyone has the opportunity to use the Q&A dialog box if you have any particular questions about graphene, and we'll answer whatever we can there. Okay, so we've got a good number of questions from the audience. So the first one, what are the commercially available graphene types suitable for coatings? And then what factors should be considered when analyzing procurement and input quality? So I don't know, Chirag, if you want to unmute yourself, if you want to talk about maybe the types and forms of graphene that might be suitable for coating applications.
Yeah, thank you. So with the coating application, so we divide the coatings market into different subsections. That includes coatings for anti-corrosion, coatings for wear resistance, and there are about 8 different market segments. It really depends on what is the target market. So, for example, if the coating is intended for anti-static, then you might be looking at a graphene with higher electrical conductivity. But if it's for corrosion protection, then it will be more about increasing the barrier properties, and at that point you're looking at a different kind of graphene. So the coatings is highly dependent on the end application.
Yeah, that makes perfect sense. And one of the ways that we can help you identify the suitable graphene supplier, we have member companies in the Graphene Council that have expertise in coatings, for example. So they may have an existing solution for your particular application, or they have the expertise in-house to do the application development for you. And that's one of the ways we help companies to connect, is to put you directly in contact with a graphene company that maybe already has experience with that particular application. The other part of the question from the attendee that asked that was, what factors should be considered when analyzing procurement and input quality? Part of that is, we can have a discussion with you about the capability of the member company to scale their production depending on how much volume that we're talking about. It may depend what geographies that you're based in, because there are companies that operate in Europe versus in the US or Southeast Asia or South America. That might be important in having a supplier that's maybe in close physical proximity. There's one question about the thermal stability of graphene. I mean, that's more of a technical question, but an important one. Do you want to grab that one?
Yeah, sure. So with graphene, it is known to enhance the thermal stability of different materials when it's added to that. For example, graphene added to polymers can improve the flame retardancy. Graphene itself is highly stable to about 500 to 600 degrees Celsius. And then at this point, it's because it's a carbon form, it starts to burn. So depending on the temperature ranges, graphene could be thermally stable.
Thank you. There's another question here specifically asking if graphene can be used as an additive in a composite polymer material to transfer some of the mechanical properties onto the material. In fact, excuse me. In fact, the Graphene Council conducted a test in a thermoset composite where we tested 19 different types of graphene to determine what impact they had to the mechanical properties, which showed positive improvement. And we have graphene added to composites is quite a common application actually these days, where it does impart strength to those fiber reinforced composites. It is compatible with either glass fiber, carbon fiber, basalt fibers, and graphene is able to be incorporated into basically any polymer. If you look at the plastics pyramid, anything from PEEK down to nylon, graphene is compatible either in a thermoset or in a thermoplastic composition. Okay, so we've got another one here. There's a question, what are the renewable feedstocks for graphene production, and what is the share for each in total volume? Chirag, do you want to talk about some of the feedstocks?
Sure. So nowadays, there's a good shift of feedstocks towards more renewable sources. That includes waste methane gas, acetylene gases, or any waste hydrocarbon gases that can be basically turned into graphene. Other thing is that a lot of the waste from different industries, that includes waste plastics or food waste, which are rich sources of carbon, are also being explored to convert them into graphene. So these are some other example is from the petroleum industries. There's a large amount of coke that is discarded every year. That coke is very rich in carbon, and there are companies who are exploring that to make sure that can be converted into graphene. So these are some of the alternative feedstocks.
Thank you. Another question asks us to elaborate a little bit on the use of graphene for electronics, which is a really interesting area. I know a lot of attention goes to the bulk graphene applications, where graphene is a black powder. Graphene in monolayer form is ideally suited for electronics, and you can think of it in several ways. One that's very exciting and I think is getting a lot of traction, and in fact, we're going to do a webinar next week with Paragraph, one of our member companies, about the devices that they make using graphene as the enabling material, is using graphene in sensing as a sensing platform. So you have biomedical applications or diagnostic applications where graphene allows a much higher level of sensitivity and accuracy in these sensing devices. The other interesting application for graphene in electronics is in thermal management or heat spreading. The number one cause of failure in electronics components is overheating or degradation of the units because of the heat cycles. And graphene is a very effective heat spreader in electronics, and we know that it is used in things like mobile phones or electronic devices or in electronic interconnects as a very effective material. So that's important. We got a couple questions about the graphene report. The graphene report is being revised at the moment. We're going through that. In fact, we've been quite occupied with the inventory of 650 data sheets, but we are currently updating that, so we expect that to come out relatively shortly. Someone did ask about the price of that. It is on our website. The graphene report itself, all 3 volumes, is $4,950, and then you can also buy individual volumes if you're only interested in those particular volumes. So thank you for asking about that. And then happy to talk also about membership in the Graphene Council, which can include a copy of the report depending on the level of membership that you have with the Graphene Council. So there's different ways to access that. And then whether you're a member or a subscriber to the Graphene report, we also are happy to have one-on-one conversations with you, often under NDA or confidential, about your application development requirements and these kind of things. So I'm very happy to talk about that. Another question, what type of graphene is best for concrete applications? So I'll refer again to Chirag, see if you want to comment on that one.
Yeah, so with concrete, a lot of people are exploring concrete. Graphene in concrete as an additive, that includes graphene oxide as a water-based dispersion, which could be added to this. It should be, this word should be taken with caution, because graphene, when it's added directly as a powder to the cement and then and the concrete is made out of it, it could or could not work depending on the grade of graphene and the type of it. So it needs to go through the application development process to understand how and at what loading graphene can be incorporated. There are different types which can be used: graphene on its own and graphene as an additive with other additives as well. So
exactly. And we see now, this is also an important point. Depending on your application, more than one type or form of graphene might solve the engineering challenge that you have. So it's not the case where only one specific type of graphene can only solve that particular application. We have seen that in concrete and cement applications, it seems to be a little bit more tolerant of various types and forms of graphene, as opposed to maybe some other applications where it is a bit more sensitive and you need a more specific type of graphene. It's also important to point out, although we discussed it, it may not be obvious, some graphene that's produced is quite homogeneous. So let's say 90% of the flakes are 5-layer to 6-layer graphene. In other graphene material that suppliers have, it might be that 10% of it is 2-layer, 30% of it is 5-layer, and 60% of it is 10-layer. And so it's not very homogeneous at all. You've got a big variation in terms of either layer count or lateral size of the primary particles in the graphene, and this can affect how it acts in your application. This is also potentially a reason why, if anybody's used graphene before and it didn't work in their application, If you didn't know exactly what kind of graphene you had, you maybe don't know why it didn't work. And unfortunately, when that happens, the material graphene writ large is blamed for not having worked when in fact it was down to the particular type of graphene or the dosing for that application. We don't want to make this sound overly complicated, but the details do matter with these applications. The reason why graphene is so exciting is because it behaves different at the nanoscale, but it also means small variations at the nanoscale affect the performance. And that's why it's so important to know exactly what you have here. Just to carry on with the theme of concrete, because we have another question there, how does it increase the performance of concrete? And this is obviously just one of 50 different vertical applications. Graphene adds strength to it, so you have improved compressive strength. It accelerates the cure rate, which can be very interesting for engineers to improve the cure rate. It reduces water permeability, which is important for the longevity of the materials. And improving the strength component would allow you to reduce the amount of cement that is used in the concrete mix, and thereby you reduce the embedded CO2. So if you want to get to a greener concrete, using graphene is one of the easiest and most effective ways to do that, to get the most reduction in CO2 for the least amount of effort and input. Okay, wow, we got lots of questions. I'll grab one here. Yeah, I know we've got like 40 questions. So one of the participants asked, we didn't mention carbon nanotubes, either single or multi-wall carbon nanotubes. As a special form of graphene, we know that there is one company out there that's making single wall carbon nanotubes that refers to them as graphene tubes. I will say emphatically, carbon nanotubes are not graphene tubes, even though it's sp2 bonded carbon. The morphology of a carbon nanotube is distinctly different than graphene, and they're not the same thing. But having said that, and by the way, the company that promotes their carbon nanotubes as graphene tubes, in my mind, is doing a disservice because it's scientifically not a correct nomenclature and it confuses the market. Having said that, graphene and carbon nanotubes can be used together. And in fact, when you're trying to create electrically conductive nets, we've seen that carbon nanotubes and graphene used in combination can be more effective to create that conductivity than using carbon nanotubes by themselves or graphene by itself. So that's interesting.
Yeah, so there's a question about the list of patents related to the graphene applications. Till today, since the isolation, let's say, of graphene, there are 150,000 patents filed for graphene throughout the 20 years period. With the graphene report, we do the complete patent analysis based on geography, types, applications, and everything. So that is all included in the graphene report. So this is something that we do on the regular basis. And one of the member benefits that the Graphene Council members have is that they have a weekly market intelligence report, which analyzes all the patents, all the research happening in the area, so that you're up to date with the latest trends.
Yeah, that's a good point. We do an annual review of patents filed to see what industries, what applications, and which companies have been filing patents, because that gives us an indication on potential application areas for commercial exploitation. We have access to global patent databases. And as part of our work, when we do due diligence projects, for example, we can do patent searches for you if you're interested in particular application areas. Is there any function of oxide elements, impurities of which are often found in geosynthesized from homogeneous biomass precursors? Most of the geo that we've seen has been made from graphite. So using modified Hummer's method to make geo. There are other ways of oxidizing graphene to get to what might be considered a graphene oxide material. But if I spread the question out a little bit more general, obviously using different raw materials is going to give you different end products. And there was another question in here about, why is there inconsistency or heterogeneity in the layer count or the lateral size of material that's produced? Why is it not all just one layer? It does depend on the raw material that you start with, because you may have trace metals, for example, that end up in the end product. It certainly depends on the production method that you use that will determine how consistent or inconsistent the product is when it comes out. And those would be some of the primary factors that determine that. So if you have people using, let's say, recycled plastic, that raw material differs depending on batch to batch, and it may or may not contain other impurities which follow through to the end product. So that, it's a very general answer to that question, but that would be one of the reasons.
So there are a few questions about the barrier properties and how to improve the barrier properties, or what are the key parameters. So when it comes to barrier properties, the two main important things are to understand the effect of the lateral size, and other is the dimension in the z-axis, which means the number of carbon layers. With that said, it does not mean that particles with smaller lateral size, or those with higher number of layers, would not have a good effect. But it's just about optimizing the right ratio and getting the best benefit for the least amount of the added cost. So that, and there is another question about the aspect ratio of GO, RGO, or graphene flakes. Like, how does it matter, and which are the applications where larger flakes would be beneficial? So from general literature that we have seen, or the experience, we find that larger flakes are usually good for enhancing the mechanical properties of composites. That includes polymers, or elastomers or rubbers. And in this case, because of the larger lateral size, they can bind the polymeric chains together in a better way. So this is one of the uses for graphene with larger flakes.
There's a question about the characterization techniques. What are the primary methods for testing? Raman spectroscopy is got to be one of the most common. And in fact, if you go to our YouTube channel, we have a masterclass on using Raman to characterize graphene. Many folks will say that you can use Raman spectroscopy to determine the layer count in material, which is true to a point, but it's not bulletproof. It's not what we would recommend to rely on Raman spectroscopy alone to determine the layer count. Because it can give misleading signals there. But Raman is one of the most common techniques for determining if sp2 bonded carbon is present. I don't know if you want to elaborate a little bit, Chirag, or we can just go to another question. But there's a whole host of measurement techniques that are used, including Raman, XRD, SEM, TEM spectroscopy, AFM, XPS for chemical composition. When we do testing, we use a whole battery of tests. Do you want to add to that?
Yeah, that's absolutely true. I mean, most of these tests do not come without any error in that. So usually when you do any of these tests, you always have a definite sample size. And it's not just about having the right technique, it's also about having the right sample preparation done. So these factors play a huge role, and none of these techniques can be isolated and can be said that, okay, SEM is the only way to measure the flake size, right? There are all these techniques. When used in combination, then you have a best result, or the most accurate assessment of the material.
Excellent.
So Terence, there's a question about what is the development of graphene in concrete industry, especially in asphalt. Do you want to take that one?
Sure. So we've just conducted some testing with the National Asphalt Technology Center, or National Center for Asphalt Testing in Auburn University in the United States. We've tested more than 5 different types of graphene, and in that case, graphene improved the aging. Reduce the aging degradation of asphalt in the asphalt binder and the bitumen binder, both on short-term and long-term stability for that particular application. In terms of concrete, this is an area of intense study, and there are live demonstrations of buildings or structures that have been made using graphene-enhanced concrete, both in the UK, in the US, and other jurisdictions. So without question, it's not if, but when graphene in concrete is much more widely adopted, especially for the reduction in CO2, plus the improved mechanicals, plus the acceleration of the cure rate. So I think that's a very exciting area. I think, to be honest, we're almost approaching an hour, which far exceeded how long I thought we might be talking about this topic today. And we have great questions from everybody. We will be able to capture all of those. But let me suggest this. If you have any specific question or you have a specific application that you're not sure if graphene might be a good fit for you, or you've tried graphene, but it didn't work and you want to see if there's a solution out there for you, reach out to us at the Graphene Council and ask us. And again, we don't make graphene. We don't sell graphene. We don't have any interest in graphene companies. We are completely neutral. Our job is to help connect people who want to use graphene to improve their products or develop new capabilities with reputable suppliers. And again, we want to emphasize your first port of call should be to our website and look at our list of suppliers, to look at member companies of the Graphene Council, and to look at the verified graphene producers as your first choice out of the hundreds of companies that claim to make graphene out there in the world. And if you have any questions, come to us. That's what we're here for. We're here to help you guys navigate this. It's a fascinating field. There's definite proof of effectiveness for graphene across all these applications. And we're here to help you navigate this so that you get to a successful conclusion with the least amount of effort, investment, and risk in just experimenting. The last thing we would do is, the advertisement where they say, don't try this at home. Just asking for a sample of graphene and playing with it might be interesting, but often it doesn't lead to an effective result because the details of how you disperse graphene into your host material and manipulate it are key to getting a positive outcome with that. And so that's what we're here to kind of help you navigate. So with that, Chirag, I don't know if you had any closing comments or if there's a burning question we want to answer before we conclude.
Yeah, questions were very interesting. And I think, as you said, we can reach out to the questions after the session as well. So anyone who has different questions, they can just drop us an email and then we'll get back to you about that. So, yeah.
Great. Well, Chirag, thank you. Thank you for your expertise. We're super happy to have Chirag as part of our team. He is a material scientist, and he's not the only one that we have on the crew, but he's very competent and can help us with some of the technical questions. So reach out to us. Let us know how best we can be of help. Thank you for your attention today. I hope this was useful and educational. Take care.
Thank you, everyone.
For more information on market opportunities and to connect with experts, contact the Graphene Council at thegrathenecouncil.org.